Astronomers just detected something impossible, a massive gravitational anomaly moving through the outer solar system. At first, they assumed it was an error, but the numbers didn't disappear. They grew stronger. It wasn't a comet, it wasn't a rogue planet, it was a black hole, and it was already inside our solar system. What happens next depends entirely on distance. A black hole isn't a cosmic vacuum. It doesn't instantly swallow everything nearby. If our sun were magically replaced with a black hole of equal mass, Earth would continue orbiting normally, which makes this even more dangerous, because the threat isn't impact, it's gravitational disruption, and gravity controls everything. But the first sign wouldn't be visible in the sky. The outer planets begin drifting off predicted paths. Neptune shifts, Uranus wobbles. At first it's microscopic, then undeniable. Space agencies compare data. Something massive is pulling from the darkness, and it's getting closer. But the real chaos hasn't started yet. Satellites begin reporting orbital errors. GPS signals drift. Weather models fail. The International Space Station performs emergency burns. Then the public announcement comes. A black hole is passing near our system. Panic spreads faster than the object itself. And then something even more dangerous happens. The black hole's gravity reaches the asteroid belt. Millions of space rocks shift. Collisions multiply. Debris scatters inward. Within weeks, meteor activity increases dramatically. Brilliant streaks across the sky. Some burn harmlessly, some don't. Planetary defense systems activate, but thousands of objects cannot be stopped at once, and Earth still hasn't felt the worst of it. Ocean tides become unstable. Coastal flooding surpasses historical records. Entire ecosystems begin to shift. But the true danger isn't the water, it's our orbit. Earth only needs to be nudged slightly, just 1%. And that's enough to destabilize civilization, because our entire planet runs on orbital precision. If Earth shifts slightly inward, temperatures rise globally. Ice sheets melt faster than climate models predict. Storms intensify. Food systems begin collapsing. If Earth shifts slightly outward, global cooling begins. Growing seasons shorten. Mass migration starts within months. Civilization isn't designed for rapid orbital change, and the black hole hasn't even reached its closest point yet. Through telescopes, stars behind it bend into arcs of light. Gravitational lensing confirms its position. Time dilation becomes measurable. Atomic clocks in orbit tick differently than those on Earth. Physics itself is warping, and if calculations are wrong by even a fraction, Earth could be slingshotted out of the solar system. Imagine watching the sun shrink year after year, temperatures falling until oceans freeze solid. Or worse, if Earth's orbit tightens instead, we drift closer to the sun. Oceans begin evaporating. Steam thickens the atmosphere. Runaway greenhouse effect begins. The planet transforms into something unrecognizable, all from an object that never touched us, and humanity can do nothing to stop it. News runs 24 hours a day. Markets crash. Governments prepare emergency protocols. Some people pray, some deny, some simply stare at the sky. Because the most terrifying part, you can't see a black hole with your eyes. You only see what it changes. And then, it begins to move away. The black hole exits the inner solar system. Orbits stabilize, but not perfectly. The asteroid population reshaped. Climate permanently altered. Humanity survives, but with a new understanding. We are not isolated. We are not safe. We are drifting through a galaxy filled with invisible forces. And if one black hole can wander into our system once, it can happen again. A black hole doesn't need to swallow Earth to end it. It only needs to pass close enough.